Okay, so uh, good evening, and it was really good time with you all, and we have discussed your problems and tried to convey some messages from university to you all. So this is, I think, lecture number 5, and today I will cover two things. First one is one talk about 40 to 45 minutes, and in this talk we will discuss about how to read a research article, and that reading research article is really a big task, and you can have numbers of research papers because you have big resources. uh, you have internet, you have Google, you have chat gpt and other uh, modern tools to collect research articles, but reading research article, it is a big task. So we will discuss how to read a research article to make one impactful paper. And the second part, that will be, we will continue that Siesta run, because yesterday we have installed Siesta, compiled Siesta by in series, and try to run some test files from Siesta directory itself. And today we will make one separate input file for Siesta and try to run Siesta using our own system, using our own material. So let us try, and let us see what will happen. And if you get any problem, any issue, please convey. And I think the sound is good. Let me check first. Okay then. So the outline of this talk, that is, just we will cover 2 point in this lecture: the components of a research article. And many of you are familiar with research papers, and you have read different research articles, so you know different components of research articles. But we will discuss what is actually the specifications of any component of any research article. And second, the main thing, the main topic, that is how to read a research article. So let me start. So this most of the research articles have a structure of IMRAD, and it's a variation. IMRAD means I stands for introduction, M stands for methodology, method, and RAD, it actually stands for result under discussion. Other components are just a simple component, but the main parameters are this. And the title, obviously, when a research article start from the title of an article, this actually summarize the main theme of the research and reflect the contribution to the theory. So that research title is actually that door of any research article. So title must be, if you have you are reading any research article, then its a title must be good and interactive. Author names and affiliation, it is given. So there may be multiple authors of a paper. If that paper is open access paper, then the multiple authors are multiple, so many. And that cartoon shows the multiple author, how to collect that multiple authors. And corresponding authors to be provided. The sequence of author is important: the first author, corresponding author, guide, supervisor, etc. So there are so many other uh, authors may be introduced in any paper. Abstract, so this is actually the summary, and mostly this is of 100 to 150, and some journals it may be extended to 200 words also. And it focuses on actually the scope, key problems, method, key findings, and applications. So this is a compact form of the complete paper. This is the summary. And keywords, and these keywords are also important. You because by these keywords, that reader of your paper, it search that paper. So as far as that online searching of that paper is concerned, it is because of this good keywords. So that introduction part, this is one important part of this paper. It actually defines the problems, and sometimes it also contains the literature review and the status of problems, its limitations, need a present study, why you need, why we are doing that study, and how it overcome present gap. So these actually defines overall presentation of paper. So starting from just a short introduction to extend up to that applications and other things, and it gives you the clear cut objective of your paper, that paper, and some additional statement and justify of the study. This is also the part of introduction. So uh, when I will talk about how to write that introduction and how to write a paper, at that time we will discuss to make one impactful introduction. So that will be maybe the topic of tomorrow's talk. So here, this is that introduction. The second part is that methodology. So this methodology is also important. This is a complex part because there are so many terminology used in this methodology term. So this actually contains the information about how the work has performed, and this helps one to reproduce result. If anyone wants to reproduce that result, then obviously uh, she will have to take the help of these methods, whatever that method is used. And uh, one important thing, that method should be transparent, because some writers try to uh, hide some information. Uh, this is wrong, this is not ethical, that should be, that must be transparent, and this novel method should be given in detail. If you have developed some method, especially sometimes this is another part of research, sometimes we create our own method, then at that time we have to give the details of this. So that method is one of the very important part of this any research article. The result, obviously this evidence to support objectives, whatever objective we have decided are given in introduction part, that will just show that part in form of different figures, table, text. So, and they, in which this table helps in showing raw or that uh, processed data, so that uh, taking a table, formation of table is very important part, and that figure helps to showing overall trend and comparison. To compare different results we need figure, because the table contains so many data, and this is actually that quantitative analysis, but for qualitative representation we need to show using figures. So figures are important part, and that figure must be self-explanatory. uh, so how one can have a good figures, we will discuss in the next talk. So it must be self-explanatory. So uh, during the writing process of any paper, figures and table, these have very important contribution in the paper. So we have to be careful, and do not include too much data in figure. One thing is important. Uh, this If figure is complex enough and it's very difficult to understand, then it is not good. And then discussion, sometimes that result in discussion, this is the same single component of a paper, but several times in good journals that result is a different, this is informative one. And if logical and we want to explain uh, and correlate the result with other research or that other physics, other model, then this discussion part is important. So discussion explain the result and correlate the problems discussed in the introduction. And this refer to uh, main purpose of study, and this explain the findings. This is the explanation part. Result is just information part, and this is explanation part. And this also show the limitations of our study, or one can say the future scope of that study. So what we have performed, what other have performed, and the comparative analysis, all these are given in the discussion part. So this is also the important part of paper. And then the conclusion, obviously this is the summary of the paper, but this is different from abstract. Remember this, do not repeat abstract. Abstract is 5 components apart, and this actually the summary of the result you have and discussed in the previous one. And this show how the work advanced from the present knowledge. And so this actually gives a that how your work is innovative, and provide scientific justification of work. Your work is how useful, you have to give in the conclusion part. And then references, each and every publications have reference sections, and journals have their own uh, mm, pattern of reference. And acknowledgement, sometimes people just leave this part, but this acknowledgement part is also important part. So feel free to acknowledge the funding agency, outsource work and valuable input from your friends who have given their role in your paper, formation of your paper. And one thing that important, during a reference, do not use these eight all type terms in reference. uh, Generally, sometimes I have observed that in reference section that the author name and et al is given, it's not good, so avoid this. Now the main part, these are components. So 5 components we have in the paper are title, abstract, introduction, and the result, and then methodology, result and discussion, and then that conclusion. And supplementary parts are acknowledgement and reference. But now the question is how to read a research articles. This reading a research article, this is a very complex task. I have mentioned this. This is very complex. The worst way to approach this task is to treat it like a reading of textbook without any reflection or criticism. If you are just reading a research paper uh, at the bedtime and reading that just like a textbook, then this is not good. You have to take care of uh, seriousness during the reading of any research article. One should begin with skimming the article to identify its structure and features. If you want to start, then just first skim on the paper and generate questions before, during, and after reading. This is the second part. First, you have to identify the structure. Second part is you have to ask some questions yourself before, during, and after reading. Draw references based on your own experiences and knowledge, and to really improve understanding and recall, take notes as you read. So make a notes, just like a textbook or a storybook. Don't read any paper, make a notes. To more The more you read and analyze your way of reading, the easier it becomes to access paper. A simple and fast technique on how to squeeze the information from the paper would save the day. So this is a successive process. And the first time, if you want to read some paper and you think that paper you will finish that paper within 10 minutes, it's not possible. But after some practice, you can finish any research article within uh, 10 minutes with good information, with the collection of good information. So how to complete that reading a paper within that 10 minutes, we will discuss. So skim the article and identify its structure. The first part, the most general usage, the conventional IMR R&D structure, an abstract followed by introduction, method, result, and discussion. Yes, I have stated earlier. And each of these sections normally contains easily recognized conventional features. So I have not very typical features, conventional features. And if you read with an anticipation of these features, you will read an articles more quickly and comprehend it more. So what are those features? Let us see. The first part, the features of abstract. You just finish reading that abstract within this 2 hours, maximum 2 minutes, 1 or 2 minutes. This is the time to cover that abstract part. Obviously, abstract is a very important part. So that abstract usually contains four kinds of information. First, purpose or the rationale of the study, why they did it, what is the reason. Second, methodology. There's some glimpse of that methodology is also mentioned in the abstract. Some results, not the complete result, but some results, what they found, it is mentioned. And the conclusion, what is the conclusion, it is also mentioned in the last part of that. And sometimes uh, that the future scope at the application part is also mentioned in that. So these are the parts of abstract, and most scientists read the abstract first. So before reading the whole paper, most scientists, and but the experts of any field, it skips right from the title to the visual, becomes the visual. In many cases, tells the reader what kind of studies were done and what results were obtained. So what actually expert does experts do? They generally just read the title, live about that introduction and that abstract part, and just to go to that some diagrams, figures, and tables, and try to obtain some good result. uh, and on the basis of their previous knowledge, because they are the expert of the field, on the basis of that previous knowledge they can judge that paper is further readable or not. And if it's good, then they start reading from abstract. So you should probably begin reading a paper by reading the abstract carefully. But my suggestion is one should read paper from abstract carefully, uh, and note the four kinds of information uh, given. Then the introduction part. For the reading of introduction, my suggestion is you should take 1 minute. Although we know that introduction serve two purposes. First, the creating reader's interest in the subject and providing them with the enough information. So one important part is the creating interest, and the second one is the providing enough information about that material. These are the important part of that introduction. And this introduction accomplishes this by leading readers from the broad information. Actually, that this gives a broad information to more specific information, and then focal point. Three parts, uh, points were parts were included in the introduction. One is the broad information of that subject, and second, some specific information is also the part of that, and some focal point, whatever that main objective of that study, it is mentioned there. And that author describes the previous works that leads to current understanding, that review article type, reviewing of the things, and of the topic, and then it converts into a specific study within the field. And but my suggestion is leave all these things behind the navigate to last paragraph in the introduction. So main part is given in the last paragraph the introduction, and this is where the most important piece of information is located. So don't waste time reading all these, because you can read after some time. If that information, most important information is in the bottom of that introduction part, read them carefully, and if you get that particular part is important, are correlated with your own interest or your own work, then uh, start reading further. Otherwise, don't waste time. Next is the features of method. The method section tells the reader what experiment are computational for the experimentalist, that experiments, and for computational DFT people, computational were done to answer the questions stated in the introduction. Second, methods are often too difficult to read. Yes, this is one thing, too difficult to read for most of us, because the technical languages and the level of detail sufficient for the another trained scientist to repeat uh, the experiment, because it contains lots of terminology. So if you are new to that field, then that will be very difficult to understand. So you either you have to Google for that terms, or just practicing reading some more paper. You can more fully understand the design of experiment and evaluate their validity by reading and method sections carefully. You can understand, but for that you have to read some uh, more text, some book chapters, or you have to search the meaning of the terminology given therein. Then the result and discussion, you can use 3 to 4 minutes, valuable minutes of your, and that result section contains result statement, what was found, and shown that data in form of either figures or table. Normally, authors do not include information that would need to be referenced, such that the comparison to other results and student materials in the that is actually given in a discussion part. And the discussion also functions to provide a clear answer to the questions posed in introduction and to explain how to result support that conclusion. So that result and discussion part, it's important obviously, but you can uh, extract the result by using the information given in the figures and the tables, and for that that 3 to 4 minutes are more than sufficient. So that introduction, method, abstract, and this result and discussion part, if you have 10 minutes, you can cover one paper to read. Now, but during the reading of a research article, you have to distinguish main points. These are these main points. In the document level, the title, abstract, keywords, some main points you have to note, and visual, especially figure in the table titles, and first sentence or last 2 to 3 sentences of introduction. So these are that key points. So you should go through that research article by pointing out these points. And in the paragraph level, if you want to study that paragraph level, then these are some phrases available in the text. If surprisingly, if this phrase is available, try to read that. Unexpected, some unexpected result is therein. If this phrase is available, so you can go through that part carefully. We hypothesize that, this is also one of the important phrase available in the research article. We develop means we think this is the new one, so you should go through that paper. The data suggested, we propose, we introduce, in contrast with previous work, had seldom been addressed. So these are that buzzwords available in a good text, good research article. So if in any paragraph you find this terminology, you can read, you should read that line uh, positively. General question to be aware of your understanding before and during your reading. Ask yourself these questions. So during reading or before, you should ask yourself this. First, who are these authors? First, you should know about the authors. What journal is this? You should know about the journal. Don't read that simple low level journals. Might I questions the credibility of the work? So this is the third question you should ask before reading. Have I taken time to understand all the terminology? So if you are using your time, so that should be fruitful. Have I gone back to read an article or review that would help me understand this work better? If you find that paper is good or correlated with your work, then one question should be asked by yourself, uh, whether you have to read some more review articles or book chapters or other articles to understand this particular topic carefully. Am I spending too much time reading or less important part of this article? Sometimes I just generally suggest don't waste time reading unimportant part. So how to decide which part is important and which part is not important, uh, after practicing reading some papers you can get. So and I have also mentioned some part in this talk. Is there someone I can talk to about confusing part of this article? If you find that some part is confusing, then uh, you should search someone to talk about that confusing part of that article, and if you get, then this is okay, good. And some questions after reading. If you have used more than 10 to 20 minutes on a single research article, then you should ask these questions. First, what specific problem does this research address? Why it is important? So you should write the answer. Is that research article is important? Is the method used a good one, the best one? Sometimes there are several methods available in the research field, and that method mentioned in particular paper, it's good or best. You have to question about that. What are the specific finding? Result obtained is good or not? Am I able to summarize them in one or two sentence? If you have gone through that paper thoroughly, then you should be able to summarize them in one or two sentences. Are the findings supported by persuasive evidence? So some application part is also important. Is there an alternative interpretation of data that the author did not address? So this is one thing. There may be some alternative interpretation. Uh, that single paper cannot be a complete one. There will be some missing point. So you should search some alternate method to uh, get that points. Next thing is, how are the findings unique, new, unusual, or supportive of other works in the field? You should ask this. How do these results relate to the work I'm interested in? If your work is related to that paper, then it's good. And then what are some of the specific applications of this idea presented here? So you should think, you should search about all this. What are some further experiments that would answer remaining questions? So after reading that paper, uh, there may be some questions uh, generated inside you, and to answer that questions you need further some more research papers, or you have to search about some more experimental methods or some theoretical method to get the answer of those questions. So these are the some specific questions you should ask after reading any specific paper. So draw inferences. Not everything that you learn from an article is stated explicitly. As you read, rely on your prior knowledge and work experience means linking your knowledge and mm, whatever you think or your topic with that paper. This is important. So if you are able to do this, then uh, you are a good reader of that particular paper. So research has shown that the reader who actually draw inferences are better able to understand and recall information. So to link that paper, the information given in that paper with your own interest or your own work, this is important. And if you are able to do that, then you are uh, a good researcher. And one thing, take notes on as you read. Don't read that book during uh, just doing some other works or just before bed, uh, because you should read, you must read, you must make notes during read. So effective readers take notes. It improves recall and comprehension. You may think you are remember everything you read in researching class assignment, professional papers, proposal, or your thesis, but the details will slip anyway. This is not good. If you think you can remember everything, this is not possible. Develop a template for recording notes or article you read. You should have one template to gather all the information uh, during reading of various papers. As you accumulate a large collection of articles, template will help you to distinguish articles and quickly locate the correct references for your own writing. So in order to write any paper or in order to write any review articles, you need to uh, collect so many information. So if you have such collections of templates of different papers, then that will help you to make a good article. And during your thesis writing also this will help, and during that paper writing, take notes as you read. These are some titles, subtitles of template you can make your own. So the template of taking notes as a research article: first, the complete citation of any paper. This is the important part you should write, because if you want to read some article and you have to give the reference, then that complete citation should be there. If that is the web access, if you are using that from web page, it's not that information is not a form of a research article, but that is in form of a web page, then you should write that URL of that web page as well as the date of access. You should note in a particular page or your notebook, or and you can collect this in form of soft copy in your computer. Keywords, important keywords you should know: general, subject, specific subject, you should note. Hypothesis, whatever that hypothesis mentioned in that paper, you should note. Methodology, especially if you are working in theoretical part, then special, the name of software, uh, some terminology frequently used in any paper, you should note down that. And the results, main results, whether that results in form of figures and tables, so you should write some figures or tables in if you are making that soft copy, then just take the screenshot of that table and paste there. And summary of the key points, uh, you must have the context, how this article related to other works in field, you should write your own by using your own sentence. And the significance of that work you should mention, because during writing of any articles or review articles, this will help. The important figures and table, brief description and page numbers of that paper you should write. And the cited references you should, and other comments, if you want some more comments, you should write. So make your own template and note down whatever you have collected the information from that specific paper. So you will have numbers of templates, a collection of so many templates, and then when you will summarize that, you will get good knowledge about that particular field or that particular topic. Okay, so I think thank you, and practice well, learn well, and apply whatever I have mentioned here, and meet you in the next session. Thank you. So this is the first part of talk, and let me start that hands-on part. Just a 2 minutes. पानी दे दे भाई. So before going to the next, let me show you some uh, example of research article. I should show you one example. Uh, Let me open this random paper I am you opening. Yeah. So this is one research article published in General. Uh, it's not opening. Okay. So the title is NI decorated PTH2 monolayer. Let me reopen this. Registration mode is not it's not good. Okay. So this is that structure, and the title is well explanatory title is there, that nickel decorated PTH2 one monolayer, that is PTH2, where nickel is doped, and it is controlled modulated by strain. So strain is applied, and the application is that for the sensing application, and the study is first principle based studies. Mean theoretical paper this is, and all the informations are mentioned in the this title. This is a single author paper, and this is that graphical abstract where some good information has been mentioned, and all part the information this is here. The first principle theory is conducted in the paper. To this material is mentioned, some results are given, and also uh, two gases have been detected sensed by this nickel doped PTH2 monolayer. So all the important informations that has been mentioned comprehensively using in this abstract. Then the introduction part, and the last part of this introduction, as I have mentioned, it's a very important one. This one, that no, this one. So this in this paper, the nickel decorated PTH2 monolayer is proposed to be novel strain modulated sensor for detection of CO and C2H2 in the ion immersed transformer in first principle theory. So this part, it is important part of this introduction, so you have to read this part only and you can get sufficient information. And then the computational part, this is that software package it is used, some methodology, these are the parts we had, it has been mentioned. uh, so these are that important part with that this k point mesh cutoff and that energy convergence, and these are the parameters. So what are these parameters, what are these limitations? And there's different references are mentioned here, So the detailed informations are given. So that's I have mentioned that this is important uh, in the complex part. And then that result and discussion. So in this result and discussion, the first part, that nickel decorated property in this manual layer is given with these figures, band plots. These are very interactive figures with this that distance. This is that distance is mentioned, and here this is not good because it's not readable properly. So avoid such type of things. This data, uh, but the interactive figures are here. And then the second part is the absorption analysis. Then these are that different diagrams, and then electronic properties of gas absorption things. So effect, and these are the good result, self-explanatory figures, diagrams are self-explanatory. Everything is mentioned here. So I think this is a good paper, and the conclusion, point-wise conclusion is mentioned here. These are the point-wise conclusion. And about the author information, acknowledgement is given, references are given. Okay, so this is a good paper, and you should try to write such a good paper. Now let us try to discuss about that Siesta run. So what we have performed yesterday, that was the compilation of Siesta, and that was in I think in Siesta 4.1. This was that. So this is that objective directory, and in this objective directory uh, we have compiled Siesta and linked with. So we have compiled Siesta and renamed as a Siesta exe. So this is that executive file, and we have linked this executive file with bin directory. So just by using one simple command, siesta.exe, this is that output, and many of you have been obtained this, and this is good practice. And but remember this here, this part is I am using that GNU Fortran, and then this G Fortran especially, and this is in the serial mode. So what is actually the meaning of this serial mode and parallel mode? So if you are a computer person, then you know about this, but if you are not, then you should really know about this. What is this serial mode? Actually, when we go to the setting of our system and know about our computer, then here, let me show you about this computer. This is the information about my laptop. So this one is memory is just 16 GB, graphics card is there, processor is here. So this is the processor, this i7, and this it is crashed by 8. Means the total number of nodes in my system is 8. If I am using Siesta in series version, means I am just using a single node. 7 more nodes uh, are remaining to use. Means uh, you can calculate just we are using 12.5% of the power of my computer if I am using series. If I use in parallel mode, then I will use all the processors, and the computational power will definitely will be enhanced. So how to compile this system in parallel? Uh, that is a little bit difficult, but I will show later how that can be compiled parallel. But let me use Siesta initially in the serial mode, and when we feel that now we need that to use in parallel mode, we will compile that system in parallel. And how that can be compiled in parallel, it is mentioned in the manual, system manual. Where is that? So that I think I have downloaded that manual somewhere. Let me open that manual. It's not here. Okay, let me download this. So the Siesta manual, Siesta 4.1.5 manual, uh, user's guide. This is that Siesta manual. So here we have performed compilation. This is that command related to uh, serial compilation, and we have performed yesterday. And this is arc make file, we did this. And the second part is that parallel. To achieve the parallel build of system, one should first determine which type of operation one requires. It requires to MPI calculation. So what is that MPI, open MPI, and that LAPAC, other things, BLAS, LAPAC, SCALAPAC, all these things are given there. I'm not going to the details of that. After using SISTA, after few steps, we can go through this and what are these terms are actually used for. And for the parallel installation, I have developed one base script, and I will provide that base script, and you can run that base script, and you can uh, install Sista in parallel. And this is that script. So command is also mentioned. What type of command you have, but remember this. Uh, you must have one good internet connection to compile this system in parallel. Remember this, and this actually takes a few minutes. So what you have to do, just you have to run two commands. This is that is script I am going to provide you. So first command will be chmod to change the mode plus X, and this is script. Press enter, and second will be just dot slash and then script this, enter. When you will enter some information uh, that will ask, and just press yes, 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 and somewhere it may be it may ask that root password, give root password, and with good internet connectivity, everything will be installed in your system. So today I am providing this script, and uh, run that by using this method. But what today's task is, we have to run some test or test file, and these are that test file available. And what I have mentioned in the last lecture, that to run this text file, what you have to do, you have to just use one single command, that is, because one make file is here, this is the make file available. If the make file is available, then just use make. uh, After few minutes, this is benzene. Yeah, so this system finished successfully, and the complete work is stored here. So many files have been generated, and uh, let me show the initial structure. Initial structure of that benzene. Uh, this is this can be shown by using GDIS with .fdf. Start.fdf means this will read this fdf file. Where is that one? No, fdf file is not here. FDF file is not here. Let me check FDF file outside this. Okay, FDF file is here. So first search FDF file. FDF file is here. So gdis star.fdf or benzene.fdf. You can write full name. So let me write full name. Benzene.fdf. So there is some issue. Don't send. There is some problem opening this. Let me try. So don't think that you face such type of problem. I always face such type of problem, है ना? So if you face such problem, then don't bother about that. Let me try to solve that. Is star.xyz. It's opening or not? Not opening. Jmol. Is there any xyz file? There is some problem in this file. Oh, this is yeah, there is some issue in input file because there are 1 2 3 4 5 6. Okay, good one. Yeah, this is. So this is that benzene file. So anyway, we will make some more practice and you will get this type of result. So just to try running different input file. But today we will run some more other input file, and in order to run that input file I am giving this graphene. So where should I start? Okay, so this is graphene, and let me start making one folder. Let me test a folder for graphene. So I am creating one folder here, and in order to run Siesta, what we need one input file. So let me copy one input file from this. So this is that input file is extended with FDF. So this is, let me copy this and paste here. Where is that? This, let me paste here. This is that input file, and one pseudo potential file is important. So let me copy the pseudo potential file. This is on that. So this will be this. So first of all, let us see what is this input file contains actually. So the first part is that system level and how to increase the size. I'm not able to zoom this. Not zooming. Anyways, so the first part is this system level. This actually give a system name. You can give any name to this, but here I have given this is as a graph UC. UC stands for unit cell. So I'm using a single unit cell, And then the system level, I have given the same as a system level and system level, both are same. Graph you see, number of atoms I am using, that is 2. So all the information you have to provide in this text file, and this is the number of atoms, and so there are 2, and the number of species 1, because I am using a carbon only, so the number of species is 1. If there is a, that just like if you are using CO, carbon monoxide, then CO, there will be number of species 2, then one will be C and second one is oxygen. So here this is 1 number of species, level of species, and 6 is the atomic number of carbon, and this is the notation of this carbon. So this 16C, this is the complete information related to the species of that material. So that graphene is the combination of carbon. So one carbon, one species is used, and 2 carbons are being used in a unit cell. And the second one is, this is that uh, lattice vectors. What is this lattice vector? This actually defines that box, simulation box. So that simulation is run in a box. So this actually gives that box size. So what is that lattice vectors, lattice parameters? We will discuss in one of the lecture. And then the coordinates, 2 atoms, so different positions are here. So the one atom is positioned here and second one is here. So these are the terms. So when you go through different text FDF files in given in a text file, then you will learn what is this. And as I have mentioned in the last lecture, that you should go through the uh, manual of this system. All the informations related to these terms, these are given in the manual. So try to learn what are this. And these K grid terms. So what is this K grid, we will define later, but these are the part of uh, this input file. And then basis set and other things, these are some conventional terms, but this is that I should say, this is actually the template of one input file. So let me delete this first, and let me use this as the one. So how this is formed? Uh, so this is one input file I have formed, and in order to run, I need this input file, and second one this pseudo potential file, and then I will run using the command. So let me show you the command. We have that binary file sister.exe in the bin. So this is sister.exe, and then I will have to give the name of input file. This is that name of input file. So let me paste here. So this, and second this line, and then this T, and then to write this output file result.out. So again, let me show you the command. This is the command sister.exe. This is that software you have installed, and link this binary file to bin directory. Second, this FDF file. FDF file is the input file, and then this is another term, this T. If you want to show that whatever happening inside that your computer, that will be shown on the screen by using this, and this is that result output. This will give the output. And let me let me press the enter and observe. Okay, so this because this has 2 atoms, so this will cover now that input file. Again, let me try to use this GDIS by using graph uc.fdf. Yeah, so this is the periodic structure, and this is that input file. So as I have mentioned, this box is known as simulation box, and its length, width, and height, it is mentioned in that lattice vector, and these are 2 atoms. So its positions are, so these are that position of this atom. Here it is mentioned x, y, z. these are the coordinates. And second, this is the coordinates of second atom, label is C here. So this is that is species. So this is input, and if you want to show that output file, then again we can use GDIS with XYZ graph.xyz. So this is that output file. Again, two atoms are there. There is no box, so just two atoms in form of output. Or in order to use Jmol, you can also use Jmol. I think we have installed Jmol XYZ. So this is another visualization tool. So this is that Jmol, and you can rotate these, and you can measure that bond length between these two atoms by using this. Just click here and click here. This will give the distance between these two. This is 1.42 nanometer. Sorry, 0.142 nanometer means 1.42 angstrom. So this is uh, the sample run of Siesta. So in order to run, you have to make one input file, and this is that output file. So here that running in serial mode, the date are given. So start reading informations related to this. These are two atoms, and output total energy is given. So make practice, and these are that total information. So what are these terms? We will discuss in some theoretical lectures on a DFT, and successively with a progressive wave we will learn all the terms. So let me make another text file from materials project. How you will do with material project? So let me start material project, one sample form. I start exploring. Let me choose silicon, carbon. I have taken carbon. So Bn, let me check. Bn, search, and that this cubic atom, there is any hexagonal, tetragonal. Hexagonal atoms are okay. Let me start this cubic atom. So this is how to perform that sister and sample file. Go to this, download CIF. So I am using this CIF in test file folder. Where is that test one? Yeah, this test folder. So let me make one folder for bn cubic. Okay, save. So by clicking here, I will inside this. Now by using GDIS, I will open this. So GDIS BNCIF, and this is, oh, so many atoms. So this will take some more time. Cubic atom is here. Number of atoms are 8. Anyway, let's try how much time this will take. So this is now save as BN cubic dot FDF. Save. Stop this. So this is that FDF file, but its number of atoms are 8, so it will take some much. Okay, let me try some more atom with a less number of atoms. But here only sites are written as 2. trigonal, hexagonal, 4. This is 4 sides. Let us try this hexagonal, trigonal. Repeat the same process. Just trigonal dot cif. Let me open this. GTIS BN trigonal. Number of atoms are still 6. Anyways, no problem. So let us use that one. Let us start from this. So this input file is not up to the mark, because I have that template input file is let me use this gallium arsenide. Yeah, this one gallium arsenide is here. Let me try this, how many atoms are here. Actually I want to run faster, so GDIS this CIF file. Let me check this. Still 4 atoms are here. Anyways, chill. Let me try this. So this save gallium arsenide FDF, this one. Okay, 4 atom is here. So actually we need this part only. Other parts are default parts given by GDIS. So I am going to give you one template, and that is the template we have used earlier in this test file as graphene UC. So let me copy here and paste this test CSID gallium arsenide. So let me paste here and let me compare. So here this is that system level, and uh, system name is given. So just copy this in the gallium arsenide and paste here. Watch carefully, and this should be gallium arsenide. So cut this, paste here and paste here. So these are that system level and system name, both are gallium arsenide. And let me delete this. Number of atoms are 4. Okay, there is no problem, but in gallium arsenide 2 species must be there, so that is 2. But here this gallium 0, gallium 1, so this is gallium, and 1 and 2 both are gallium, so this is 1 and 1 gallium. This is the label 1, 31 is atomic number, and let me delete this. Second is arsenic, so AS, this is 2, 33 its atomic number. So you have to manipulate this as 2 and 2. So 2 atoms of gallium and 2 atoms are arsenic are here, and then rest of the things I should keep as it is. Just copy here to there from the template and paste here. Just forget about other things given in that file generated through GDIS. So paste this. Okay, so that some default parameters are here, and how we will get that parameters we will discuss after some practice. So now let me run this. But in order to run, I must have PSF file. So let me get two PSF file I need, because we have two species. So one, so let me download that PSF file. So gallium.psf pseudo potential. Let me search in the internet. So this database is open. Yeah. So this is that pseudo potential database. So let me gallium. Where is this gallium in the periodic table? Gallium arsenide. Arsenide is here. So let me click here. So this is that PSF file used in Siesta. So right click and save link as, and paste this in this gallium arsenide folder. This is one, and then press back and go for gallium. So where is this gallium is? Urban. Oh, I have forgotten periodic table. Yeah, this one is gallium. So let me use this no semicolon. Save link is, oh, this PSF file. Okay. So let me try to run. So I have two PSF files, one for arsenic, second for gallium, and this input file. And let me make one separate folder. Gallium arsenide run, test run, and 1, 2, 3, cut, paste inside. So let me check again. So all the information required are that system level are given, number of atoms, species, and pseudo potential, and with default terms are here. So let me now use that sister command to run again sister.exe with input file gallium arsenide.fdf t result.out. Enter. So depending on your RAM size and the processor, I am using a single processor because this is in series version. So, and number of atoms are 4. So this may take some time. Okay, so this will take some more time. I'm stopping here, and try on your own system, and try to make some more FDF file, and run Siesta. But remember this, just take one or two atoms, maximum four atoms, otherwise uh, much more time will be consumed. And try to watch that input file, FDF file, using GDIS, and output file from XYZ file. That XYZ file gives the output either through JMOL or through GDIS. Okay, so it has been over. So this is run. So let me show you GDIS file first of input. So this is that input, and then GDIS star.xyz. This is that output optimized. So jmol star.xyz, this is that output. And now you can see, go to the label and symbols. Oh, it's not showing. And you can measure the bond length. So click here and here. The bond length is 2.45, and here to here bond length 2.47, and here to here. So these are that bond length, different bond length. Anyways, so hope now you can able to run Siesta. Practice yourself, and show me the result. Thank you all.